Hey folks, this is Dr. James McLean. I'm hosting a debate here for a student from McGill, okay, who wants to discuss the concept of the definition of number with none other than John Gabriel. Okay, so before we do that today, we're going to discuss what the rules are going to be. And these rules are pretty simple, okay? So we must give respect to each other. I also think we should respect the timer as well, all right? No swearing. I don't think we're gonna have a problem with that. Should be fine, I reckon. You know, we're all grown ups here, I hope. We have ideally no talking over one another. It's easier said than done, but I will mute you if needs be. Okay, pretty classic. All right. Then the format of the debate is going to be like this. We're going to have a 30-second introduction from each of our guests. We're going to have a 3-minute opening statement from each of our guests. Then, because our student from McGill here, okay, has decided to engage John, he's going to provide a 5-minute engagement directed at John about his definition of number. Then we're going to have a 5-minute response from John. Then we're going to have a 5 to 10-minute open discussion where, if necessary, I will ask questions to both of you. You know, maybe you guys have missed a point of each other or something like that. All right, and I'll maybe try to highlight anything. I might even have nothing to say. Who knows? So then we'll have a 10-minute open discussion between both of you. And I will probably put myself in there at the bottom as well on the stream. And then we're going to have a potential second round of 10 minutes open discussion as well. We'll see how it goes, you know. And we'll sign off the debate. All right. So now, not that this is essential, but I would highly recommend it. Please take notes of some form, pen and paper, type it up. It's very easy to forget what somebody has said, especially during their opening statement. Things go very quickly. All right. So, do we have any questions? Any questions at all, folks, at the moment? None? Okay. So what we'll do is we will have each of you introduce yourselves now. So here we are. All three of us are here. Let's go. Who wants to go first? Milton, after you.
Yeah. Hello. Hi. So, I'm a student at McGill. I study computer science and philosophy, and I'm always interested in like what is the kind of statement that someone is making when they ask for a definition of number. And my sort of goal with this debate is to give a maybe more philosophically justifiable perspective on the modern definition of number
Okay.
and sort of explain how this interacts with some of the kinds of claims that John is making.
Sure.
For a very brief rundown of my opinions, I think that number is not the kind of thing that it even makes sense to define. I think that the unit
Mm-hmm.
of a mathematical statement is like a proof or a proposition.
Okay.
And so number is just an element of a proof. And we can make statements about entire proof systems.
This was the
These are going to
introduction,
be.
just to let you know, not the 3-minute opening statement.
Oh,
It's okay.
yeah,
We'll
okay,
keep the
sorry.
recording going. No, it's fine. But basically, hello,
Yeah, I guess like
Milton.
just very broadly, I'm
Please.
interested in the kind of statements that people are making when they make
Thank you
mathematical
very much.
statements, and I'm here to sort of explain my
Yeah.
current understanding of what these things are to someone who I think more than anyone else completely disagrees with everything I just said.
Okay.
In terms of introductions, that's
We'll,
all.
we'll see how it goes.
That's all. I guess personally, whatever.
Sure.
I'll be happy to hand it off to John.
Okay, John, introduce yourself, please. 30 seconds, roughly.
Well, as you all know, I'm the popular John Gabriel. Channel's been growing at 300 a month and exceeding that number every month. People are warming up to my ideas, which is a good thing.
Good.
And I'd like people to understand mathematics, not simply to have to go through a math undergrad degree and think that they've learned mathematics when they haven't actually learned anything past linear algebra and calculus. But we'll
Okay.
get to that.
All right, thank you for the
That's pretty.
introduction. Thank you very much. Okay, so since Milton here, our student, is the challenger, Milton, would you like to share your screen, please, so that we may get
I
this sorted?
would be happy to.
Thank you. So once that is done, I will put the focus on
I've shared the
you.
right screen.
Perfect. Right, so now I'm going to open up the clock here. All right. It is going to be 3 minutes in this case because it's a 3-minute opening statement. Okay.
Mm,
When you're good to go, I'm just going to click the clock here and then go back to you on the screen. Okay. So
Okay.
let's go.
I'm not able to see the clock when I'm tabbed over to my presentation, so like a 30-second warning
No problem.
would be appreciated.
If you also want, you can
Um,
watch my stream as well because that has the clock on it, if you wish.
I
I
think I
will.
just have to like press. I don't know how.
All
Yeah,
right.
I have to have this tab open to press space to go to the next
Yeah,
slide.
that's fine. So if you're ready to go, are you ready to go?
Absolutely.
Okay, I will give you a reminder halfway, and then with 30 seconds to go. Okay.
Perfect. Okay.
Right. Get me
So
started.
I'm here to give. Sorry.
No problem.
Okay, sorry. Yeah, hi. I'm Milton. I'm here to give a brief presentation on what is a number. My presentation is broken into about two sections, where first I'm going to go over like my intuitions about what a formal system is, what kind of problems in math and philosophy they were trying to solve, and then the second half I'm going to go into a more sort of explicit critique of like the John's understanding as I understand it. So first we're going to talk about what a formal system is. So in the history of mathematics, generally we say that the very first formal system was Euclid's postulates. The first four are generally uncontroversial. Of course, I can draw a straight line from any point to any point. I can produce a finite straight line. I can produce line segments. I can produce circles, and right angles are equal. What else would they be? However, for a very long time in the history of mathematics, people did not like the fifth statement. As you can see, the other four are sort of introducing elements of this formal system, explaining how to create points, line segments, circles, and right angles, or they are sort of describing how these things interact with each other in very basic ways. However, this fifth postulate, if two straight lines, if there's a transverse line, they make interior angles. You can extend the two lines and they will never intersect if they are parallel, or if they do intersect, it will be on the side of the acute angles. This postulate is weird. And for a very long time, people have been trying to prove the fifth postulate as a theorem of the first four. This was going on all the way in ancient Greece and all the way up to
You have a
like the
minute and a half.
1700s. Oh God. Okay, my presentation is a bit too long then.
That's okay.
However, the problem that people discovered is that there are valid models where you can have the first four postulates, the ability to draw line segments, shortest line between any 2 points, all right angles being equal, but where the the fifth postulate does not hold. One example of this is the surface of a sphere. Here I've drawn a triangle. I have a line. I have two lines perpendicular to that, and yet they meet at the pole of the sphere on the other
1
side.
minute.
1 minute. And so the sort of question that this brought up in the sort of philosophy of mathematics is just like, what are these statements about? My intuition, and almost everyone's intuition, is that these were statements that were necessarily true of like an abstract, absolute space. However, it appears that they're bizarre in the sense that they are now contingent on like the nature of that space. And so, whereas before they were thought of as necessary statements, now they're just sort of a consequence of a specific choice for the way that space curves. And you see in the history
30
of
seconds.
mathematics that after. Perfect. Okay. And you see after that in the history of mathematics, there were many, many other paradoxes. The first one is very famous. It's Russell's paradox, and it's about the existence or non-existence of the set of all sets. The second one, this is Newton's definition of infinitesimals, where he wanted to have positive real numbers that were smaller than every other real number. And all of these were sort of statements about the
That
existence or
is
non-existence of
time, my
things.
friend.
I'm so
Time.
I didn't
That's
it seems I
okay.
didn't
Don't
manage
worry
my
about it.
time
Don't
very
worry about
well.
it. If you could stop sharing your screen, listen, we're gonna have plenty of time for you to bring up more of your slides. Don't worry about it, okay? So do not feel like I'm cutting you off unfairly. You will have plenty of time to share those things, okay? Do not worry, all right? We will make sure you
Perfect.
get to share your slides, okay? So now, to go back to us here, John, would you like to share your screen, please? And then we'll do the same. And I'm gonna turn off maybe
Uh,
the
Actually, I
reception.
don't really have a presentation
Okay,
as Milton did. I'm just basically going to talk. I think that's the
right.
easiest thing to do.
So you'd want to talk at this point. So you're
Yeah,
gonna,
can you put that clock up on the screen like you had before?
yeah. So we can do this clock here.
Good.
So you want to skip your opening statement and you want to go to a 5 minute. Uh, Sorry,
No,
no,
I'd like
three. You
I'd
want your
like
3 minute
no,
response. Okay,
I'd like a 3 minute response.
sure. Right. When you're good to go, I will start the timer and I'll click back over to you. Sound good? When you start speaking, I
Yep.
will click the timer. Go.
Okay, so you mentioned computer science and philosophy. Yes, a lot of things are mentioned in mainstream mathematics, but a lot of these terms are not understood. And of course, you said something really ridiculous like number doesn't make sense to define. I've never heard of something such as, as absurd as that. And also, somebody who uses the word intuition obviously doesn't know what it means. So I'd really advise that before you use that word, you actually look it up. Then, as for formal systems, thank goodness the ancient Greeks didn't bother with that garbage, because if they did, you wouldn't have mathematics today, any mathematics. Then, of course, you don't understand that the 5 requirements are not axioms, and they are derivable from nothing, and they are dependent on the previous definition, starting with the first line. And the 5th axiom, as you so call it, is not an axiom, and it's not a postulate, and it can be proved. So, also, there is no such thing as a Riemannian geometry. All geometry is Euclidean. The fact that you're talking about a sphere is Euclidean geometry. Euclid had an entire chapter on stereometry. If you don't know what that word means, you can look it up. It's a Greek word which means solid geometry. So why do we need a sound definition of number? I can't see the clock anymore, by the way.
Oh, can you not? Okay,
Why do we
keep
need a sound definition of number?
a
Well,
minute and a
it's
half.
the most important concept in mathematics. That's why we need a sound definition of number. You can't define number as you wish according to your whimsical notions, right? So the best definition is decided according to that which is well defined, not that which you think you can define philosophically and according to your computer science notions or anything else like that.
Minute left.
What I'm telling you, most of your, I can see the clock, by the way, most of your objections are not even objections. Formal systems, excuse me, you know where the word formal was introduced? It was introduced when people decided they were going to be authoritative over mathematics. You don't get to decide what is mathematics. Mathematics is not decided by the majority. It is decided by fact and reason.
30
Your
seconds.
opinion doesn't matter in mathematics, okay? Your opinion doesn't matter. All that matters is what is fact and what is reasonable logic. You wouldn't even know how to do basic arithmetic if the ancient Greeks thought according to the ridiculous way that you thought and the ridiculous way that you came out in your introduction. Absolute garbage. What else can I say?
All right, 5 seconds to go. Pretty strong stuff. Okay, so that's our timer up for that one. Right. What we're going to do now is, Milton, you get to, if you want to share more slides, you can do this. I don't know if you want to. So we're going to go back
Oh
to
yeah, no, I mean, I should have spent my first 3 minutes maybe going over more abstractly, but the slides I think are good. I have more definitions of a formal system that I think are directly responsive to some of the stuff that John brought up.
Sure. So you
So
would
yeah,
like
if
to share
possible,
your
I'd like to just go
screen.
back into sharing the
I will
slides.
now set the clock up for 5 minutes. 1 second. I'll reset this. Go up to 5 minutes. I'm gonna actually turn that clock off, I think, or at least the ding sound. Let's see, mute tab. Right, so we're gonna view your screen. There's a 5-minute clock here. Now, when you're good to go, you will have 5 minutes. So how many times would you like a reminder?
Give me a reminder at 1 minute and at 30 seconds.
Again? Okay, sure, no problem. All right, let's go. When you're ready, go ahead.
Great. And so basically, the sort of thing that I am making is that mathematical statements are the rules of a kind of language. We have our sort of informal, fluid language, which is not capable of making the kind of statements that can be definite in the way that they need to be for mathematics. And so we replace our sort of pragmatic grammar with a formal grammar. John says that a formal system has something to do with authoritarianism. It's not that at all. It has something to do with the form of the statement. So modern mathematics conceptualizes its rules as the sort of valid ways that we're allowed to write down sentences and the valid ways that we're allowed to change one sentence into another sentence such that it preserves the kind of properties that we're interested in. And so we have in modern mathematics very, very many systems. You have set theory, which conceptualizes numbers as classes of cardinality as of sets, the empty set being 0, the set containing the empty set being the simplest set we can make with cardinality 1. We have type theory, which conceptualizes number as the repeated application of functions. So given like a successor function and an initial value, 0 is the one that returns the initial value, 1 is the sort of interaction of functions that applies that successor function a single time. In category theory, this is the one that I lack the most knowledge of, but I believe it's also foundational to modern mathematics. It conceptualizes numbers as a kind of well ordering. So 0 is the natural number with no elements less than it. 1 is the natural element with precisely one element less than it. In first order logic, we have 0 and the successor function given via just axioms. And then in higher order logic, typically you have an axiom that defines what induction over the set of natural numbers is. And then finally, we have Gabriel numbers, which seem to me to be a valid way of defining number. They take intuitions of ratio and they seem to make them precise. And that's sort of the theme with all of these, is that there are many different ways to take an intuition of number, of amountness, of repeated application, of iteration, or of ordering, and making them precise. And so something becomes a mathematical statement when we have taken a certain set of intuitions of geometry, of amountness, of quantity, of ordering. We then explicate the concepts by making them formal in a way that is clearly communicable. That is sort of the goal of this explication process. Someone wants to know exactly what my statement is, so that if I've made a mistake in reasoning, it's easy to point out. And that's the point of a formal system, is to catch errors in an argument. And so we engineer formal systems and then formalize these concepts by setting them in definite relations to each other so that errors can be pointed out. And that's basically sort of my perception as to what a number is. It's a certain person's intuition for cardinality, for geometry, made formal, made the kind of thing where any error in reasoning is immediately point outable. And then finally, I'd like to engage in a little bit of arguments against John's system. This is quite brief, but we're clearly able to construct the line segment of length √2, and most of John's definitions of arithmetic involve the manipulation of line segments in ratios. It seems to me clearly the case that if I have a line segment of length 2 and the unit, I can produce a line segment of length 2 √2. I can compare this line segments to other lengths, and it seems to function as a number, even in a purely geometric way. And so you're allowed to say that it's not a number because it's not rational, but it seems that it sort of looks like a duck, quacks like a duck. There's no reason why I can't just allow myself to call it a number if I can construct it so easily. And this is just sort of an idea that saying an infinite expansion of √2 is not nearly as contradictory as you might think, because the proof that there is no rational, there is no, 1 minute, yes, that there is no rational, there is no ratio that is exactly √2. This proof is finite, and so when I write down square √2 is equal to an infinite decimal expansion, I'm not making a claim that I can actually write a long series of numbers that are precisely equal to the square root of 2. I am saying that on one side, I have a limit of a series of rational numbers, and on the other side, I have some construct in geometry or some construct as like the root of a polynomial, and that I'm merely saying that in my formal system, I'm allowed to say that in every instance where I have the square root of 2, I could also equivalently have this sort of abstract infinite thing that, again, is not in fact infinite because I'm writing out the 3 dots, and I'm just saying that these 3 dots refer to that limiting process. And so while we are performing proofs about infinite objects, the proofs themselves are all finite. I'm never actually dealing with an infinite object, nor am I claiming that I need to deal with an infinite object.
That is time.
And
I'll let you
that's
finish.
time. Okay.
I'll let you finish. Finish it because it looks like we're nearly done. Go ahead.
Yeah, and then so I guess my last one is that there are just some problems with John's formal system. It's, as far as I can tell, impossible to find a q, comma, I think it's mn now, for non-polynomials. You seem to require algebraic manipulations of your equations. You cannot extract h from sine via algebraic manipulations. You can't even define sine with a closed form algebraic thing. So John has this definition of sine and cosine that just don't make any sense.
Right,
His definition of angle is no longer rotationally symmetric, etc.
Well, there'll be plenty of time to discuss that. Please stop sharing your screen while I bring up all 3 of us at once. Okay.
Oh, I stopped watching. I did not stop sharing. There we go.
There we go. Okay. So now we're going to go back to odds 3. Right, I'm going to reset the timer. 1 second. John, you can have an extra, 40 seconds if you want as well, if you wish. Right.
Yeah, I
Are
think I
we
need.
good to
I
just
think I do
before?
need an extra 40.
Say that again?
I do need an extra 40 seconds.
No problem. I will put that in the timer because I figured Milton was nearly done, so we figured
Yep.
may as well. Why not? You know. Let me now add that in.
Before you
Yes.
start, I do not want to be interrupted. Just have the timer on the screen. You
Okay.
don't need to warn me when the time's
No
up. I
problem.
will stop exactly when the time is up.
Okay.
Okay?
No problem. Right, John. Please share your. You wish to share your screen or?
I don't wish to share my screen. I'll just address his concerns
Okay.
directly.
Right. Uh, when you're ready, start speaking.
Okay, so well, he talked a lot about formal systems, and I find that really incredible because when you say something like valid ways to write sentences, is that not authoritarian? Of course, it is authoritarian. You don't have to need valid ways to write sentences. You use common language, precise language to describe yourself, and you say exactly what you mean. Okay, symbols are not special. So that's the kind of BS that I hear all the time. Then he talks about set theory cardinality, and you can't actually have cardinality without number. What do you mean by cardinality? You can't have bijective cardinality. And he also talks about piano with his successive function. Well, what he doesn't really realize is that piano's very first axiom says zero is a number. So it already assumes that a number is a well-defined object. Now, I know that Milton doesn't care about a definition of number, but you should care if you want to understand mathematics. It is the most important concept in mathematics. That's why you should understand and have a definition of number. So he also talked about explicating the concepts, which, is a kind of hand waving language that I've heard so many times, and catching errors. Excuse me, and pointing out errors. When you catch errors and pointing out errors, you're assuming that you know better than the other person, don't you? Because what you're assuming is that you have a formal language in which you get to dictate rules. That's not how it works. And thank goodness my brilliant ancient ancestors didn't think that way. Otherwise, you wouldn't have mathematics at all. You wouldn't even know how to count. So then he talks about cardinality and geometry, where he clearly doesn't understand what those terms mean. If he understood what cardinality is, he'd know it means number. Then he said he could construct a number. Milton, you can't construct numbers, my friend. You can, to reify a number on a number line requires 3 steps. You actually have to be able to draw it, you have to be able to put a marker, and then you have to be able to say what the measurement of that number is. And no, nobody says you have to write an infinite decimal expansion. That's not the point. There is no infinite decimal expansion. Do you understand that? Because at what point does it become unique? Does it become unique after 300 million light years? What kind of garbage is that? There is no such thing as infinity. It's total bull. Never mind. I'm not supposed to use that term. So basically, square root 2 is not a number of any kind. In fact, square root 2 as a number doesn't exist. In order to have a number line, you need to be able to reify it. And I've got lots of articles for you to do that. And I'll place those in the link of this YouTube rather than go over them. And then it seems to him that constructing a number is possible. I've never heard such an absurdity. Finally, look, here's the reasoning. The best definition is not decided according to one's whimsical ideas. It's not decided on formal uh, rules or definitions. That's nonsense. Because if the Greeks had to think the way you thought, you wouldn't have anything. You wouldn't have geometry. You wouldn't have uh, arithmetic. You wouldn't know where it comes from. You don't even understand the basic definitions of arithmetic. And you made several false claims about my statements without backing up your opinion. Do you know how I look on that? I look on that as really despicable and condescending. You don't get to do that without backing up what you say. You need to back up your proofs and your claims. You provided no proof whatsoever. You issued a whole lot of garbage claims that don't mean squat. Okay, so when you make a claim, you back it up, little boy. Then
Easy, John.
the best definition is not decided according to the majority of academics. It is decided according to reason and decided according to fact. You don't get to decide things and to decide the rules. There are no rules in mathematics. Mathematics is not an abstract decision on the part of a group of mainstream communities, mainstream mathematics academics. Mathematics is the abstract science of measure and number, nothing else. Okay. And if you want to go further into that, I'll provide links in the articles. In fact, I'm going to cut it short now because I'm a little worked up.
Okay.
And I think it's despicable that this young man has this attitude, but that's okay. I'll let it go. That's it.
Sure. We will cut the timer early. All right. I will now put us back to three of us, like this. And this is where we can have a 10-minute open discussion between all of us. I can also enable the clock here, and I can reset that to 10 minutes. So originally the plan was going to be that it would be 10 minutes between you guys in particular. However, yeah, would you like to proceed with that, having an open sort of discussion at this point? Everybody okay with that, more or less?
Yeah, that sounds fantastic.
Okay, right. I will start the timer for both of you. I may interject. I may have to mute one of you guys at one point. We'll see what happens. But right, good luck, folks.
Okay, yeah. I mean, I have my notes. I'd love to run down some things. I do apologize for not having explicit references to your PDFs. There are quite a few. I would love to go over a couple of the things that I've said. I know. This is a fun debate for me, not exactly a research project.
But wait a minute. I have to interrupt right now. You made some false claims about me not having closed formulas for trigonometric formulas. Those are lies. I do have closed forms for trigonometrical formulas. And if you don't understand them, I'd be willing to explain to you. So
Yeah,
those
I
things are
think
not.
I think that's a perfectly fine direction to take this in a little bit. My sort of quibbles with your trig functions are beside the point, I guess, to the rest of the things that I want to get to. And like, I guess I'd like to talk more about a formal system. I'll give an example of formal systems not being the kind of thing that are decidable by the majority. I think the most famous example of this is probably Russell's paradox. Mathematicians for a very long time had been trying to come up with set theory, and they were very happy with the definition. They had come up with a set theory that enabled them to do all kinds of the mathematics they wanted. They were happy with their ability to define the integral, etc. However, one philosopher, one person showed that within this formal system, you could ask the question or come up with a statement, a sentence equivalent to asking the question, does the set of all sets contain itself? And if you answer yes to the question, the set of all sets
Stop.
that don't contain themselves.
You're starting to basically just list a whole lot of mainstream claims that are absolutely false. They're not agreed upon by everybody. There are many mainstream academics who know about Russell's paradox, who know that set theory is not mathematics, and who
I
will
guess, yeah, that's
disagree with
so
you.
that's the point that I'm
Excuse
trying to
me,
say is that,
let me just finish. I gave you a chance.
of course.
So don't repeat stuff that we all know. Say what you think is wrong with my definition of number. Remember, we're not discussing set theory or Peano, who was a non-mathematician in my opinion, and you don't get to call mainstream mathematics academics. Mainstream academics mathematicians, because as far as I'm concerned, none of them are. Okay, so and just state what you think is the definition of number. After all, I thought that's what we were going to be debating on this debate. I don't know what you're talking about. You're running down mainstream statements that have absolutely nothing to do with number. Cantor, Russell, Hilbert, Frege, none of those guys actually defined number. They battled desperately hard with it, but I did. A number is a name given to a measure that describes a ratio of magnitudes. You don't even have a definition and you don't care about it because you do not understand mathematics, nor do you care to understand mathematics because your goal is to obey rules. Okay. In other words, you think that because somebody makes a statement about infinity, that you can use it as a concept in mathematics. You can't. And I disagree with you on that.
Okay. Yeah, I mean, I haven't provided a definition of number because I don't think that a definition of number is a reasonable thing. I don't think that there's any reason why, I don't think there's any sort of fact of the matter that we could refer to conclude that one definition of number is correct, whereas another definition of number is incorrect. These are sort of abstract objects. I've certainly never seen a number in the real world. They're not the kind of thing that you would expect to give a definition for. And this might seem sort of unreasonable for a lot of people, but if you've ever tried to seriously give a definition to the word chair, you'll understand that when you really boil it down to things, a lot of the concepts that we take for granted are actually just sort of intuitive things. The point of a mathematical statement is to take some aspect of my intuitions, formalize it, and then have it be the kind of thing that's critiquable. So I brought up Russell's paradox not to go over how brilliant a sort of dead British guy was, but to explain the fact that even though there was a pre-existing formal system, one person, not a committee of sort of mathematicians or whatever, one person was able to show that this entire definition was flawed. He produced a sentence that should have been true and false under the current understanding of mathematics. And what we saw is that people realized that their formalization of their intuitions of cardinality was wrong. That was the sort of standard opinion after Russell introduced his paradox. And what we saw happen is exactly what you would want to happen. An error was demonstrated, and a new formal system, which talked about the concepts in a slightly different way, now you no longer had unrestricted comprehension, was introduced.
All right.
And so this
think-
is mathematics functioning properly. This is not a
You're
group
using
of
up more
people
time than I've used.
coming up with rules. This is how progress happens in mathematics, and that's sort of what I'm here to talk about.
Okay.
So
John,
you can
let me
respond.
speak. Yeah, let's go.
Okay, so let me address your non-arguments. First of all, you're hand waving because you're talking about intuition. You're talking about the point of mathematics. You haven't even defined mathematics, but you're talking about the point of mathematics as a rule that you have in fact accepted, which I haven't accepted. And thank goodness that my brilliant ancestors didn't accept either, because I shudder to think what state the world would be in if they thought the way you did. So number is not something you can say to yourself, it's a luxury, or it's something that we need to basically relegate to somebody's individual interpretations or ideas. You can't do that. You can't. And you talked about Russell's paradox. Russell was a nobody, in my opinion. And set theory is not mathematics. So I don't even know why we're discussing that, because we haven't agreed to discuss set theory. I could discuss it with you in another debate if you wanted to, but this is not about set theory. This is about what the definition of a number is. And so far, you haven't given a definition of number. Okay, so you need to bear that in mind, young man. Listen, we're here to discuss the definition of number. So if you're teaching somebody mathematics, and you want them to know the most important concept and how to do arithmetic and how to do measure and how to do everything they need to do in their fields of STEM, whichever it may be, they need to understand the concept of number. It's as simple as that. It's not a luxury, it's a necessity.
Okay. So again, I'm not ever trying to talk about an individual person's or ideas. You say I haven't given a definition of mathematics. I guess I'm happy to define mathematics as the thing that happens after people have agreed on a convention for manipulating formal systems. It's discovering the consequences of axioms, discovering when our axioms produce inconsistent results, and then modifying those axioms to get at a valid expression of our intuition. So a valid definition of number, from my perspective, is every single thing I put on that slide. Gabriel numbers as ratios, classes of cardinalities of sets, etc. All of these are totally valid definitions of numbers insofar as they provide formalizations to our intuitions, who we can then interrogate. This is explicitly not about an individual's intuitions. This is about the ability for people to come together despite having very, very different intuitions, right? It's the ability to talk about the things and the structures that overlay these formal systems that we're talking about. It's a kind of communication, that's why I refer to it as a language, and it's a kind of sort of formal arithmetic. And so that is sort of what I consider to be the valid mathematical statements, demonstrations that certain assumptions lead to contradictory results, or the ability to construct other objects that we want to construct and sort of talk about their properties. And I guess maybe as a question, if someone claims to exactly understand your definition of number as like a set of ratios, how would you go about checking this? You would give them exercises, and they would demonstrate to you that they were capable of manipulating elements on a piece of paper and communicating about these elements in a way that followed the rules that you expected them to follow. The thing that we're always referring to are these sentences and these diagrams. And we can imagine and debate about the sort of ontology that may or may not underlie them. But I don't think that mathematics is an ontological science. I think of it as a sort of logical science, a kind of language and a way to explain what we mean when we say things. So I'm happy to sort of go back to you,
40
have you
seconds
respond
left
to
of
that.
this 10-minute portion. Let's go. John,
Am
would you
I
like
going to
to
be
add
allowed
anything?
to respond to that?
Yeah, of course.
Yeah. Okay. So
Yeah, so you got 30
let me
seconds,
respond.
and then we'll take
Oh,
a short break.
look, as I've told you at the beginning of our debate, Milton, mathematics is not a thing that happens when people agree on things. That's nonsense. And thank goodness again that wasn't the case. Axioms are beliefs. Okay, they are all about being formal, 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 and formalness is about authority. Okay, it's about saying, listen, you can't say this because this,
That's our
and
first
if
10
this
minutes.
happens, then you get a contradiction to that. Okay, and then you asked me a question: why do contradictions? Well, you didn't. You asked me, how do you check my definition? Well,
Pause there for now,
it's very
John.
simple.
What we're going to do now is we're going to tag me in, and what we're going to do is we're just going to have another 10-minute open discussion, okay? Except I will also say a few things, but I will let you finish your particular points that you were making, okay? So we're going to bring in the next 10 minutes now. I have a few things I'd like to add in at some point, so hopefully I can go after John if that's okay with both of you, okay? All good?
Okay,
All
so
right, go, John.
just to answer his question, how do you check on my definition of number, Milton? It's very simple. It works. You do arithmetic with it. You do measure. You are able to do everything you do in engineering, architecture, computer science, which is what you know about. You're able to use it in every possible way. The nonsense that you learn in set theory is not usable in any of that. It has never been used in any field of STEM, contrary to what you think. And all I have to tell you is that when you make a claim, you need to be able to support it, not rattle off what's written on a Wikipedia article or about what somebody said about formality. I hear you saying that, but that's not going to help anybody who wants to understand mathematics. You saying, oh, rule number one, rule number two, rule number three is what you need to do mathematics. That's not how it works, because people don't understand things with rules. They just do when they see a rule. They say, oh, that's a rule. I've got to do it. It says stick to the right-hand side of the road. I've got to stick to the right-hand side of the road. Okay. Use axioms, which is absolute nonsense because axioms are beliefs. Thank goodness the Bourbaki group didn't convince everybody, and I'm one of them. And all I can tell you is that I disagree just about with everything you said. I don't have a problem saying
I'd
that.
just like to
Thank you very much.
Yeah, thank you, thank you. I'd just like to interject. I suppose one of the things that I do find interesting about the way modern mathematics has gone personally is how do I explain this? The most fundamental thing that humans do, right? I'm talking like we are like literally let's swinging from trees at this stage, okay? You're an animal or whatever. You compare things, right? The most fundamental notion that anybody has is big stick, large stick, whatever, versus this stick. So every single thing that we do is done via contrast, right? And I mean that in a sort of philosophical and also a physical way. Another thing is at the end of the day, with the way axioms have maybe been presented in modern maths, I understand why it's happened and how it's happened because it's very difficult to explain certain things. But that being said, I do also find that it's like they've kind of like given up trying to even explain like basic things for rational numbers or whatever. They just assume it's a given sort of deal, right? And well, the reason I want to relate that to like how we compare stuff is because how do I explain this? It's difficult to word this, what I'm trying to say. Let me think. Actually, Milton, if you want to go, let me think on this. I need to think how I want to say something.
Yeah.
Go ahead if you want. Go.
Yeah, of course. And so, like, I do think that explaining things is a very valid and important process. I think that a lot of mathematical progress couldn't have been done without people getting genuine intuitions for specific concepts in their head. That's just sort of obviously the case. However, the question is like, how do we know that we've all agreed on the same set of intuitions? How do I know that, like, when I'm thinking about measure and ratio, maybe I'm thinking about it on the surface of a sphere? We have modern physics, which shows us that space is meaningfully curved. You know, maybe I think that that's my valid model of a plane. John Gabriel obviously disagrees. How do we come to the conclusion that the models that we have in our head are equivalent? I think that the way that we do that is by this sort of a cycle of concept engineering, understanding the implications of my formal system, and then re-engineering my formal system. I think that this is sort of the cycle that produces very good and very useful mathematics. John said that he was able to tell that his definition of number was great because it worked. And I think if that's the standard that we're going with, I see almost no reason not to prefer my understanding of number, as this is what clearly works very, very well. I don't understand how
Hmm.
you can claim that your definition of number is correct because it works, and then my definition of number has like gotten us to the moon and built cell phones. Um,
The
that just seems like
I remembered what I
a
was going to say. Sorry to interrupt. Sorry
of
about
course.
that. When it comes to axioms, it's like so the reason that I think that why I understand how it's happened. The thing is that we are not responsible for this universe and its construction, right? And there's
Mm,
clearly, you can see in chemistry, you can see in physics that there are some very interesting building blocks that can be described mathematically. Now, listen, of course, abstract things exist in the brains of humans. However, our benchmark for reality comes from the universe. It comes from our own physical experiences and what's been made. I'm not saying that it's God or the gods plural here, okay, that are responsible for this. I'm not making any claims, but what I'm trying to say is that there is a very definite structure to what's happening here. And I think if humans argue about what that correct structure is, well, some humans will see that the maths is like, oh, we use it to model reality. We know it's not reality. Newton said this. Numerous people said this. But the point is that there's still some very interesting connections and like you can see things like geometry in nature, fractals of your veins, your lungs. Um, Cut a shell in half, you're going to see some interesting swirling patterns. And are they a perfect golden ratio, for example? Definitely not. But geometrical ideas do and are ever pervasive in this universe. So when we talk about axioms, it's like saying that we get to dictate almost how this whole thing, this experience that we're part of, is being created in a way. And I think that's what John is trying to say is a problem with him, is because we didn't get to decide where we are now up to a certain point. I mean, our construction, the universe's construction, and such like. But many people will separate mathematical modeling from what I'm talking about here. I believe that John says, actually, guess what? Turns out that there is a good way to realize well-founded concepts, from what I can understand, that are responsible for this existence, that we're in fact technically responsible for what we're doing now, if we're honest, right? I think that I just sort of want to add in. Sorry to interrupt you, Milton. Continue.
Yeah, no, I think that
Hold
that's
on.
a
I
Sure.
think it's my turn now.
Okay, sure.
oh yeah, no, I was just
Okay,
gonna say
so
that I think we should move on to John's definition of a well-founded concept and sort of get
Yeah.
more
Okay.
from
Go
his
ahead.
perspective.
Go ahead.
and I'm about to get to that. So, Milton, you said that your understanding of number got us to the moon. Actually, it's not your modern understanding. The only numbers that have ever been used to get us anywhere, not only the moon, are the rational numbers. We've never used real numbers. So that's basically a non-argument. And then again, you mentioned the word intuition at least 5 times. Tell me very quickly in one sentence what you think intuition means. One sentence.
A concept that I think of as true, for which I can't give a good definition as to why it's true.
No, that's not the definition of intuition. So for homework, I'm going to let you go and study, look up the definition of intuition, and you'll be very surprised that it doesn't mean what you thought it meant. And then, of course, you think that agreement is necessary for well-formed knowledge. It's not. Believe it or not, the reason the elements has withstood the test of time is that it has been written down, not perfectly, but written down better than any other mathematical work in the history of humanity. So please remember this when you make gigantic claims like these things work because of what you thought, of what modern set theorists thought. They're absolutely false, and you're deceiving no one but those naive young people who are trying to understand the concept, which is very important to understand. And well-defined concepts, getting to your point, they're very important in mathematics because if you don't have well-defined concepts, you can define anything you like, and you can get contradictions, and you can change the rules, and you can have formalism, etc.
Continue, Milton. Yeah.
Okay, yeah, absolutely. So, um, yeah, so I mean, I just Googled the definition of intuition. I guess I might as well say it. It says the ability to understand something immediately without the need for conscious reasoning. Uh,
Hmm.
I guess the
Interesting.
way I use the word intuition includes the ability for intuition to be wrong. There are all these famous studies about how, and then more broadly, I'm thinking about
Hmm.
You used it incorrectly, Milton.
Okay,
The
I
thing is, the
apologize.
thing is, everybody uses it incorrectly, from what I can tell. It's not just you, Milton. Like,
Yeah, okay.
it's
So
everybody. Like
let's
any maths channel you go across, they'll use intuit physics as well. It's like it's a very commonly used word, and it's actually misused, to be honest. And
Absolutely.
no
Let's say
offense, no
for the
offense. You know.
purposes of this discussion, whenever I say intuition, I actually mean intuition subscript Milton, which includes the
Right.
ability to
Okay.
be wrong
I
about
see.
things.
Your interpretation in general, right? Okay. I
Yeah.
see. That's fair enough. Okay. Um.
Notice how what we
Yep.
just did there. We discovered that I was using a word in a way that wasn't conventional, and then
Yes.
sort of tracked down where that convention was and improved my concept in a sort of cycle.
Yeah,
Um,
interesting. Oh, i.e., so what? I mean, I'll pause the timer here. I think we do have a little bit of open discussion now, real open discussion more than before. What you're trying to say is that, at least from what I can understand, if I misrepresent something, please tell me here. The idea is of modern maths is you refine the process, right, and you knock stuff out that doesn't work, for example, right? That's my
exactly.
understanding, right? Okay. Now,
Absolutely.
listen, in some ways, I do actually sympathize with that understanding because it's I do sympathize with it because it's like people sort of see it as like maybe a science or whatever that you're trying to like chip away at and try to like refine further and further. So I do get that side. However, the irony is that the rules that are responsible for what we're doing right now physically are there, have been there, and will always be there, at least in my opinion, right? And we're just like flashbags trying to discover what the hell's going on, right, in our own unique way up to a certain point. Um,
Yeah,
but yeah.
absolutely. And you can believe, like, I think a lot of philosophers of mathematicians are, uh, the word that they would use is fallibilists, where they think that these, like, genuine sort of mathematical principles exist. They just doubt our ability to ever actually express them.
Mhm.
And the sort of reason why I think that this is a nice place to be is because none of us know the mind of God. None of us can just like peek behind the curtain and see if our numbers are correct or true or exist in a mind independent manner. The only thing that we really know how to construct that is genuinely mind independent or at least interdependent, to me at least, seems to be these formal systems with definite rules, right?
Okay.
People struggle to understand all of the philosophers of the 17th century who tried to put forth a definition of real space, and almost all of these were contradictory, mutually exclusive with each other, and most importantly, lacked any way to disprove any of them. I think that like you can only really have good knowledge if that knowledge contains the conditions for itself to be falsified. And the way we'd falsify a mathematical statement is by pointing out an error in the proof or
Mm-hmm.
by showing that the formal system that was used to create it has contradictions. Um, and I guess that's sort of what I would say
Okay.
on that matter.
Right.
I'm
Well, we're
curious what
nearing
John
the
has to
end of the
say
debate
about
in general
potential
here.
fallibility.
We're nearing the end here. This has been quite a long time, I think, especially with like little pauses in between. John, would you like to add anything?
Yeah, I'd just like to summarize. So
Sure,
it's
sure.
very interesting that you said the mind of God, because mathematics has nothing to do with the mind of God. And well-formed concepts don't depend on the human mind. That's quite an quite an arrogant thing to even think, because if aliens exist, then they can't think of these concepts because it's not in their minds. So that doesn't make sense to me at all. And then you said, you talked about falsifiability, but so far you haven't been able to falsify anything. You haven't even been able to back up your claims. You haven't understood the language you've used. And really, Milton, one of the things you need to be able to do is to communicate precisely. It's very important. And not in symbols, right? Not in symbols, in normal human speech, because symbols, by the way, are basically backed up by normal human speech. So you can't turn around and say mathematics is a language. It's not a language at all. Human speech is a language, and I know several languages. So mathematics is not a language at all. That's a misconception. And finally, I'd like to say this, that, you know, I I have anger issues when I get on YouTube. And now I'm bringing the thing back to me. You haven't defined number, I have. So when I define number and people tell me it's incorrect and they can't back it up, that's not a good thing, you know. You need to be able to back up whatever you say. And so far, you haven't really said anything express the same stale views of the mainstream. And because I don't want to hog the time anymore, I want to thank you very much for coming on this debate with me. I appreciate it very much.
Yeah.
And I'll pass this over to James, and he can finish it off. Thank you.
Okay. Um, I can see a 51-minute timer on my recording software right now, so we probably should call this quits soon. Thank you very much to both of you for coming on this. Milton, you are always welcome to come back. You're welcome to direct message me anytime you want. You're welcome to the
And
Discord.
me.
And John as well. Listen, if you're genuinely interested, by all means, just ask himself, ask me, or whatever. We'll do what we can do. Thank you very much for coming on. And yes, this is the debate being signed off. Thank you very much to both of you. Say bye for the camera, please. See you, folks. Thank you very much. I will stop the recording.